Okay then, Mr. Wickens here with another fun math video. It's going to be a quick one because I have a dance class in a couple of minutes, so this has to be a quick lesson, but that's what I should probably be doing because my other one was super long. So I'll do this one quickly. Some quick little math facts on how to find the surface area of a cylinder, and then that'll be that. So, also I have a really cool intro song. Look at me, I'm still talking, making this video longer. But anyway, I have a really cool intro song from someone in my other class, so I'm definitely going to throw that in soon. So, cylinders. How do we find the surface area of them? So, what's a cylinder look like? It looks like that. Maybe. So, how am I going to find the surface area of this shape? Again, I have to find the area of all the faces on this shape, on this object. What do those faces look like? Well, we have circles, a circle on the top, a circle on the bottom, and we also have this curved part, this tube part. So, if I were to make a cylinder with a piece of paper, I would go like this, right? And we see very quickly that if I want to think about calculating this surface area here, I can actually think about calculating the area of the rectangle that creates that cylinder tube part when I wrap it up. If I calculate this area, then that'll give me the same area as the tube itself. So here's the important thing to notice. If this length was, let's say, 10 centimeters, right? Which part of this rectangle is 10 centimeters? Let's fold it up and let's see. When I roll it up, when I roll this cylinder up and put it up next to that, I see that this is going to be 10 centimeters. So when I unwrap it, 10 centimeters is the short side, so be careful about that. So I have a rectangle here, and if this rectangle was representing that circular part, this part would be 10 centimeters. But the question now stands, what is this length right here? Well, let's put another number on this cylinder. Let's say that the radius here was, what's a good number? I don't know, 2. I like that number. Even number, the only even prime number, it's a cool number. So how can I figure out what this length is going to be here? And here's the trick. When I wrap this cylinder up, right, this top length, when I wrap it up, it creates that circle, right, the outline of that circle. And we have to ask ourselves, do I know how to find this length of a circle if I'm given, say, the radius? Well, what is that called? What is the outside of that circle called? That outside of the circle is the circumference of the circle. So if I find the circumference of that circle, that's going to end up being the length of that long side. How do I find the circumference of a circle again? That's something we have to remember. But luckily for you, that equation, that formula, might be above the whiteboard there in the classroom. So if this was 2 centimeters, how do we find the circumference? Well, the circumference, as the formula says, is 2 pi r, or 2 times r times pi. So in this case, because r is 2, we get 2 centimeters times 2 times pi. So that's going to be 2 multiplied by pi multiplied by 2 centimeters. Hopefully that's still on the screen there. 2 times 2 is 4. So I have 4 pi centimeters. So that circumference is going to be the length right here. 4 pi centimeters. And we're almost there. Now we have the dimensions that we need here and the dimensions that we need for this circle. So in order to find the surface area, we need to calculate this area and this area here. So area here of a rectangle, we already know. It's length times width. So it's going to be this 4 pi multiplied by 10. So you can put this into your calculator, and 4 pi should give you a number. You could go, if I quickly pull out my computer, I don't carry a calculator around that much, to be honest, so I have to use my devices. If I do 4 times pi, that gives me 12.566. So this is actually 12.566 centimeters, like that. So I could multiply 12.566 centimeters by 10 centimeters. That would give me around 125.66 centimeters squared, if I did length times width there. If I kept the pi by itself, you don't have to do this, but if I kept the pi here and I didn't use this number, I would do 4 times pi times 10. And the question that you might ask yourself, what is 4 pi times 10? It turns out I can actually multiply those numbers together, 10 times 4, and have it be 40 pi. If I have 10 groupings of 4 pi, I have 40 pi centimeters squared. If you put that into your calculator, you'll get a pretty close number as well. So one of those two works. I'll use this one because I'll put it into this total here. So I've calculated the surface area of the outside part. That's going to be 125.66 centimeters squared. Remember, the units are squared. Then I have to add the area of this circle. Well, the area of that circle, if I make some room over here, the circumference, remember, was 4 pi. If I want to find the area of this, that's going to be, again, the formula on the board, pi r squared. In this case, kind of ironically, r squared is 2 centimeters squared. So this is 2 times 2, this is 4 centimeters squared. 4 pi centimeters squared. Ironically, the area is the same number as the circumference. No, it's just a coincidence. Don't think that that always happens. Just based on the numbers I randomly chose out of my head. So one of these circles is 4 pi centimeters squared.